Hello, in this video we are going to go over solving absolute value equations, okay? So first we'll start with just a warm-up, all right? What is an absolute value even mean? So we've talked about these functions a little bit when we did our parent functions, all right? Absolute value functions are these vertical bars. And what the absolute value function does is it takes whatever number ends up being inside of it, and it makes it positive. So if it's already positive, like this 4, then it's just going to stay positive, okay? If it's a negative number inside the absolute value, then it turns positive, all right? So -8 turns to 8. So positive numbers stay positive, negative numbers turn positive, okay? Just looking at a couple of different things here. All right, if a negative sign is out in front, right, then that means, so the 9 inside the absolute value stays positive 9. The absolute value sign goes away, just like here, right? This just became 4, except now we've got the negative sign out in front, right? So that negative sign stays out in front, and so this turns to -9. You can do math inside of it, right? So it doesn't turn all the numbers inside positive right now. It turns the final number. So we could do 91 minus 107. That's -16. -16 minus 4, that's -20. And then it turns positive, so then it would turn into positive 20. So you got to do the operations first. This one, okay, the -2's out in front. So the -2, again, just kind of like the normal negative, will just stay out in front until the very end. So 14 plus 17, that's 31, right? And then we've got 31 minus 19. Now, you really have to draw these lines kind of big, I guess, so that it doesn't look like a 1. And then we got to do 31 minus 19, so that should be 12. So now we've got -2 times the absolute value of 12, so this just becomes regular 12. And then -2 times 12 would, so our final answer here would be -24. All right. So that's kind of how you work with absolute values and what absolute values are. Now, when it comes to actual equations, okay, if x equals 7, what are the possible values of x? So you should hopefully realize that you have two values that x could be, okay? First of all, x could be 7, right? But x could also be -7, okay? And that's the key to absolute values, is it's kind of like quadratics. You get two answers, okay? Because 7 stays 7, -7 turns into +7. So either 7 or -7 are answers here. Now, if the absolute value of x equals -4, what are possible values of x? All right, here, you should hopefully realize that there are no solutions, because the absolute value sign turns numbers positive. So it's actually impossible for an absolute value to equal a negative number, okay? So that'd be no solutions. All right, so this right here, this is those last two examples. That's gonna kind of guide how we do this. So when you're solving absolute value equations, the first thing you want to do is isolate the absolute value, okay? And then you're actually going to create two cases, okay? Because you have the positive case and you have the negative case. We'll talk about extraneous solutions later, but okay, so we want to figure this out. So kind of going off of what we did above, all right? Whatever's inside the absolute value right now could equal 5, right? But whatever's inside the absolute value could also equal -5, okay? Both of those solutions work. So that's where we kind of say we create two cases, all right? You've got the positive case and you've got the negative case. So x minus 9 could equal 5, but x minus 9 could equal negative 5 too, because if x minus 9 equaled negative, ended up equaling negative 5, then that would turn into positive 5. So you really have two equations to solve, and then once you split it up, you're just going to solve them separately, right? So we've got x equals 14, add the 9 over in this case, and we've got x equals 4, all right? So you should be getting two answers for these. Now, the thing is that you have to check to make sure your answers are real answers. I know that doesn't make sense, but sometimes with absolute values, some fake math goes on, and you could get an answer that's not a real answer. So you need to plug them in. So we're going to plug in 14. All right, so we've got 14 minus 9 equals 5. 14 minus 9 is 5, so we get absolute value of 5 equals 5, and that's true, right? That gives us 5 equals 5. So this is a real solution. Then we got to plug in 4, okay? So we can also do 4 minus 9 equals negative 5. 4 minus 9, that's negative 5, so the absolute, oh wait, sorry, I messed up, guys. That shouldn't equal negative 5. I was kind of looking at this equation right here, but you're plugging into this equation. Okay, so that's my fault. So this absolute value of negative 5 equals 5. That's also true because the absolute value of negative 5 is 5. So both of these solutions work, okay? So we're going to, again, move on to a different one, okay? So again, 2x could equal 18. Or 2x could equal negative 18, all right? So we need to check for both of these cases. So divide by 2, we get x equals 9. And then divide by 2, and we get x equals negative 9. All right, so if we check these, plug 9 in for x, we've got 2 times 9 equals 18. 2 times 9 is 18. So that's true, all right? 18 equals 18, so that is a solution. If we plug in negative 9, we've got 2 times negative 9 equals 18. That gives you negative 18 equals 18, and this is true because the absolute value of negative 18 turns it to positive 18. So this is also a solution. Okay, so, you can keep doing these, all right? I want to find one where it doesn't work. Okay. I mean, you can do any of these problems, all right, just like we did above. Well, I'm going to move down to some of these down here. You guys can do C and D on your own, and then check it on your own to make sure you did it right. If you have a problem like this, okay, where you have another number going on outside of your parentheses, outside of your absolute value, before you split your equation, okay, first you have to get your absolute value sign by itself, all right? That's the key here. So if we subtract 3 over, we get absolute value of 8x minus 6 equals 0, okay? So you can't try and split up your absolute value until it's alone, because what would you do with this, right? So this is a special case, though, because this actually won't split up at all, because there's not a positive 0 and a negative 0. So this is just one equation, all right, where 8x minus 6 equals 0. So we can add 6 over to both sides, get 8x equals 6, divide by 8, and you get x equals 3/4. All right, 6 over 8 simplifies to 3 over 4. Now, when we check this, all right, we still want to plug it up into our original equation. All right, so we're going to check this. We've got 8 times 3/4 minus 6 plus 3 equals 3. All right, and now you're just kind of checking it with order of operations. So we need to multiply here. So 8 times 3/4, that's 6. 6 minus 6 is 0, so this is the absolute value of 0 plus 3 equals 3. Now the absolute value of 0 is just 0, so that goes away, so we just get 3 equals 3. So we did it correctly, all right? So the other beneficial thing of checking for extraneous solutions is that you know if you did it right or not. So x equals 3/4. What would we do on a problem like this? Same thing, okay? We need to get the absolute value equation by itself, so we need to get rid of this 9 and this -4. Think about it just like solving, okay? We're going to get rid of this 9 first. So that's going to give us -4, absolute value of x plus 10 equals -24. Now we're going to divide by -4. All right, that gives us absolute value of x plus 10 equals 6. Now we can split it up, right? Now we will split it up because the absolute value part of the equation is by itself. So now we know that x plus 10 could equal 6, or x plus 10 could equal -6, okay? So now we can solve this, all right? So now we can subtract 10 on both sides. And so we get x equals -4 as one of our solutions. We can subtract 10 on both sides here. And we get x equals -16. And now we want to check our two answers. All right, so we're going to be plugging our two answers up into our original equations. We've got 9 minus 4, absolute value, -4 plus 10 equals -15. So we want to check to make sure this is actually a real solution. So start going through your order of operations. -4 plus 10 is 6. All right, the absolute value of 6 is 6. So we've got 9 minus 4 times 6 equals -15. That's 9 minus 24 equals -15. -15 equals -15. So that one works. Now we want to, I'm just going to copy this over because we're kind of doing the same thing here. Except now we're plugging in -16, all right? So -16 plus 10, that's -6. The absolute value of -6 is +6. So -4 times 6, that's -24. And again, 9 minus 24 is -15. So again, both solutions worked here. So you might be wondering, you know, when might not one of your solutions work, okay? So let's go ahead and look at G here. We're almost done, okay? What do we want to do here, okay? So the absolute value, right, is by itself, but it equals x. So again, we need to split this up into two equations, all right? One case where it equals x, and the other case where it equals -x, okay? And so we're going to solve here, all right? Subtract by 3x over here. We get -4 equals -2x, divide by -2, and we get 2 equals x. So there's one of our possible solutions. Subtract by 3x over here, all right? We get -4 equals -4x, divide by -4, and we get 1 equals x. So will both of these solutions work? I actually think they will, okay? So let's check them, all right? So we've got x equals 2, so I'm going to plug 2 in there, and it equals 2, all right? So let's see if this works. We got 3 times 2, that's 6, all right? 6 minus 4 is 2, so we've got absolute value of 2 equals 2, which is true. So that solution works. Then we're going to plug in x equals 1. So we've got 3 times 1 minus 4, and the absolute value equals 1. 3 times 1 is 3. 3 minus 4, that's -1. the absolute value of -1 is 1, okay? So that one also works. So again, both of these are solutions. Now let's look at this example, okay? This example is a little bit tricky. The absolute value sign again is by itself, but we've got a full expression over there, all right? So what are we gonna do with this, all right? We still need to split it up into two equations, but it's kind of equaling the positive case, right, which is 4x plus 5. When it equals the negative case, all right, it has to equal negative 4x plus 5 like this, okay? So you have to distribute that negative sign. So that's going to become negative 4x minus 5, all right? This is the thing. Don't forget about that part right there. So we're going to solve both of these. I'm going to subtract 3x. So we got 2 equals x plus 5. Subtract 5, and we get negative 3 equals x. On this one, I'll add 4x over, this time to this side. So we've got 7x plus 2 equals negative 5. Subtract 2, and we get 7x equals negative 7. Divide by 7, we get x equals negative 1. All right, so let's check both of these answers and see what happens, okay? So answer number 1, negative 3, we plug that in. We've got 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. 3 times negative 3, that's negative 9. 4 times negative 3, that's negative 12. All right. Negative 9 plus 2, that's negative 7. Negative 12 plus 5, that's also negative 7. Now, is this case true? No, it is not, okay? The absolute value of negative 7 is positive 7, but this stays negative 7. So does 7 equal negative 7? No, okay? So this is actually not an answer, okay? That's what we call an extraneous solution, all right? It gives a solution that is not actually a solution because of some funky math that goes on. So that's why we got to do the check, all right? You got to check for extraneous solutions, all right? So now we can check negative 1. Let's see if that solution works. So we've got 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. So 3 times negative 1, that's negative 3 plus 2. 4 times negative 1, that's negative 4 plus 5. Negative 3 plus 2, that's negative 1. Negative 4 plus 5, that's positive 1. So this actually will work because the absolute value of negative 1 turns it into 1. All right, so this only has one solution, x equals 1. The other solution is what we call extraneous, okay? So that's it. That's what we're doing today, all right? Go ahead and try the practice. Now make sure you read the directions, all right? Because I think there are some odds or evens possibly going on. I can't remember if that's this assignment or a different one. But if you have any questions, all right, you can message me, let me know. Thanks, and have a great day.